Reaction time!
Reaction time is the time it takes you to react to something. Factors that influence reaction time.
Average speed is all of the speeds calculated and divided by the number of speeds over a trip. Instantaneous speed is the speed taken at one moment.
Oh, there we go.
Oh, there's a snake. I should probably brake. To calculate braking distance, you have to use the equation d equals vf minus vi over time. To calculate it, let's say that our final velocity is 12. Let's say that our initial velocity is 6. Let's say that we traveled for 5 seconds. We should put the units in there. Now, what's the first step? We should multiply everything by 5. D. 5 equals 12 minus 6. What is 12 minus 6? Class? 6. Now, D times 5 is equal to 6. We have to divide 5 by 6. I mean, divide 6 by 5. To get what D equals, which is 6/5, which is
1.2.
1.2. Our total braking distance was 1.2 meters per second. Our whole thing was in meters, just so you know.
In the bottom was seconds.
5 seconds.
Seconds, yeah.
Done.
What is acceleration? Oh, that's right. Acceleration is the rate at which the velocity of a body changes over time. With time. Over time. With time. Yeah, with time. Over time.
Go.
Positive acceleration means that the change in velocity over change in time is positive. So we assume for negative, it's the exact opposite. The change over time with velocity is negative.
Positive acceleration. Change of speed. Here we see graphs of acceleration versus time. Now at rest, it's going to look like this. Here's acceleration, here's time. It's going to be almost unnoticeable, but there will be a line coming across here. Alright, here we see positive constant velocity for acceleration versus time. Now it's going to be a straight line here going across the time because it's going towards this constant velocity. It is not accelerating, so acceleration will not go up. But it started with acceleration, which means it's not going to be at 0. So for here, for positive acceleration, we're going to see that it's going to have a constant acceleration with the time, which is going to have the graph looking like that. Because as time goes on, we have a constant positive acceleration. Now we're going to look at velocity versus time. So velocity will be up here and time down here. Just like with acceleration versus time, at rest you're not going to see really any change in velocity because time goes on, there's no velocity targeted. Alright, for velocity versus time with a positive constant velocity, we're just going to have a straight line go across here because there's no acceleration to move it up or down. For velocity versus time with positive acceleration, we're going to start out here because this acceleration will rise, but soon it'll curve because it reaches its maximum acceleration for its velocity. Now we're going to look at position versus time. So position is up here, time is down here. Like all the other cars at rest, it's just going to be constantly here because the position is not moving, but the time is increasing. For position versus time with a positive constant velocity, the graph's going to look like this because since it's a constant velocity, the car is going to keep gaining a position, increasing a position. For position versus time scenario 1, here's what's going to happen. The car is going to be at rest up until this point where it starts gaining a velocity, and when it stops, it's going to go here because the position isn't increasing. It's at the same, but the time is still increasing. It'll start rolling down the hill, going backwards, until it comes to a friction stop. It's not going to go back to the same position that it did though, it'll just come to a position stop. Alright, so for velocity versus time, the car's going to be at rest around here, where it's going to pick up its velocity to the point where it's going to start slowing down because it is stopping and running out. And then it'll go down the hill, down like this. The velocity is going to decrease until it hits absolute zero.
Okay, so what is centrifugal force? It is the force that acts inwards on an object that's going in a circular motion. Okay, so how does it affect a car turning? Well, so you're driving along and you're turning the wheel, so the friction of your tires hitting the road actually makes you turn inwards and makes you have a turn so you don't hit this roundabout here